So during this assignment, we recreated the MINST dataset, but in this case, we have done this with um, with different neural layers, such as the convolutional neural network, convolutional 2D layer, and max pooling 2D layer. What does that represent? Is that after pre-processing, we we apply this, just specifying how many filters each of these layers is going to have. How convolutional works is that you must apply to the pixels a specific filter and do a multiplication, dot multiplication. With that, you will be getting feature map. With a feature map, you're gonna just get the parameter that represent um, the features that you're gonna get. So each of these layers just contain the weights of each of the perceptrons. What you're gonna do is apply 8 filters. The kernel that you're gonna do it, the kernel or filter, it's the one that you are multiplying to get the feature map. Once you have done that, you're just also gonna put if you want a padding. So padding is this process where you recreate based on the corners of your image the other pixels that you're generating, so that way you're getting the um, you're getting the same information of the corners of it, and you're not losing anything while getting this kernel multiplication. After that, you need to specify the activation function that you're using, and the input just is the size of the sensor that you are using. Once you have done that, you are just applying the max pooling to the layer, in which it is a filter that you're gonna use. You're just gonna get the maximum values of the feature map that you just generated. After that, you will just apply the flatten layer, and after that, then 2 dense layers. That way, after compiling the model with the same metrics that we have previously used. So in this case, the sparse categorical cross entropy, because we're working with floats float inputs. You're also gonna use an optimizer and a specific metric. Um, Finally, what you are doing is to train the model on the 5 epochs, and then you're just plotting that with history, with the history on the accuracy as well as the loss function. This way, you're seeing the accuracy in this case, and you are also seeing the loss versus the epochs. As we can see, as we have trained the training set in different epochs, we are performing a better model. We're getting a better model train. Finally, after the evaluation, we are just gonna do uh, we can just start predicting the model. We can see that the test accuracy was for the evaluation using the test. It was an accuracy of 98%, and a loss function of 0.05. And even here with the training set, we are just getting a really good accuracy of 0.99. That way, we can say that the model is a really good model. After that, we can just do the predictions by showing it in this format. When we are showing the number, the digits that it has, and at the right hand, you're just seeing what was the probability of the model to be of the prediction. Um, so this is basically a really good format because that way you can see, for example, in the four, that even though the highest prediction was four, there were several other predictions that was not the best case. Um, Once we have done that, we are also now going to experiment with real names, sorry, with real numbers. For this case, we need to do a pre-processing for getting the image and then to train it and then to modify it so that it appear as the ones from the dataset of MINST. I first tried to do it in real work, in real life, um, from a notebook. However, it didn't work because you have the lines. Probably if we are training it with in whiteboard paper or in white paper, it works better. Despite that, after the things that we do, it was first to import the PIL image library and also PIL image ops. We train it so that we create these files. So just these are just the names of each image that we are getting, so that when we search for it, we get the next image. We just try with three different images with that it was a nine, that three and seven. After that, we create the test labels where you apply an array where you will be setting or just labeling each image that you're getting. Once you have done that, the test image, you're getting a list of test images. That this it will be just to get the final images, and that you after that will just convert it into a tensor. So this way you get path, you open it, you then change the image and the color image to um, instead of being the back of it white, you just convert it to you invert the colors so that you get the background of it, that you get it now black, and that even the number it converts it to white number. Once you have done that, you resize the image so that you can get an image 28 by 28, and you will be also changing the data type to a float. Finally, you just create this to make the tensor, and you append this to the array, to the number array that you will be generating after it, so that it can enter into the prediction model. Um, Once you have done that, you make the predictions, you make the subplots, and we can see, well, you apply the same code that it was applied before, and we can see that two of the three predictions were done correctly. However, the number seven, it didn't work. So for next videos, I think it will be really good if we work a little bit more with object detection, and probably also with border segmentation. But it was useful to understand the convolution and how it works.